When a model learns your secrets, it never forgets.
Yeah.
You can't delete, it can't undo that because it's not like a field in a database. It gets infused into the model and that's it. You can't go after it.
Tom, thanks so much for being
Thanks,
back
Nick.
on the Built for Trust podcast. Just finished your keynote, up on the main stage.
Yeah, good fun.
Really, really great. I tell you, I love
Full
it.
house too. Congratulations to you all for drawing a crowd.
Oh, thank you. Yeah, it's like actually our biggest crowd, standing room only
I
for
know.
you. And
well, there's a reason.
Yeah.
Right. This AI stuff is driving change that everybody needs to understand. Right. And ONUG is the place to learn it, in my opinion. So.
Thank you for that. And we try, to do that. And I think, it's like this is becoming. Over time, I think it is now, it's just only going to grow bigger. It's really the epicenter of like, where do you figure out how to build an enterprise AI, company?
Yes.
And I think that's really what's happening. And your keynote fed right into that because really, it's like when I hear, you speak and now Cisco really speak, you're really kind of rethinking and reimagining what infrastructure means and what it does.
That's my job at Cisco. You know that, right? And so, and that's relatively new. It's like in the last year, but they've asked me to go figure out what does a data center of the future look like? And it's going to look a lot different than the data center we know today.
Yeah.
Which, yay, let's get on it.
Yeah. Well, we did that 3-tier and now 2-tier, and now there's like all the GPUs.
Scale out, sort of bringing the cloud scale and then the infrastructure for large scale AI compute is dramatically different. Than the infrastructure we've had for Kubernetes-based apps or for VM-based applications.
Yeah, I think one thing that I get from the whole GPU experience around networking is how fundamentally different the protocols have got to be. Obviously Ethernet had to be fundamentally rethought and and redesigned for that. And so but we also know like that these systems, these AI infrastructure systems, the GPU clusters, in our community. The large enterprise, they may have 1,000 GPUs, maybe some might have 10,000 GPUs. They're not of the scale of that you kind of hear.
Most enterprises are just starting on this journey, and there's a lot of friction around it. So one of the advantages we have at Cisco is we have a multi-billion-dollar business selling components to these monster AI factories, the big giant model trainers, and we've learned a bunch of stuff about how to make this work at scale. So let's start with some of the basics.
Yeah.
When we talk about a network, the network that we know and love in the enterprise today, that connects the servers to the storage, the firewalls and load balancers, we call that the front end network. It's traffic coming in. But as you start to deploy GPUs, the GPUs need to talk directly to each other. So GPU to GPU communication is really a different class of networking. And we refer to that as back-end network. There's a scale up and a scale out component to the back-end network. So scale up is going to be something that's really going to come from the GPU vendors, where they build interconnects that allow these GPUs to talk directly to GPUs at blistering speeds. But that's going to go to, 78 GPUs, something like that, 100 GPUs. But you're going to have applications that need 1,000 GPUs.
Right.
And when you need 1,000 GPUs, then you use what's called a scale-out back-end network. That today we are doing with Ethernet-based switches. And so, but the mode of operation, the way we do load balancing, we do packet spraying across the network, the buffer sizes. When you're running GPU to GPU, it's more like an interconnect. It's almost like a patch panel for a computer as opposed to a general purpose front end network. So we have a different mode of operating. Our silicon is programmable, and so it knows, I'm doing back end network, and then it'll apply different algorithms for doing traffic handling on the back end. Than for the front end. But the point is, it's all the same Cisco switch.
Wow, I didn't know. So the silicon actually
changes.
Wow,
it detects, and we work with NVIDIA on that, where we have a handshake back and forth. Like, okay, this is back end networking, and we've got to run these different load balancing algorithms, and then the different buffer sizes to handle that traffic. And it's crazy fast traffic, 800 gigs.
Right? It's we're kind of like 800 gig, kind of speeds right now, and
and that's not enough.
And we're kind of in Star Trek land, with optics like in Ethernet speed. So it's
so we could almost have a separate podcast on this, which is at the cutting edge, the top of the market. To go from 800 gigs, somewhere between 800 gigs, 1.6T and 3.2T, somewhere in that zone, we're going to reach a point where we can't move electrons fast enough over a copper wire, and so we're going to have to go directly to optics.
Yeah.
That's a whole nother realm of complexity.
So that would be kind of optic to optic, GPU to GPU connection.
Well, it's
so
what
the
we
whole
call
backplane.
co-packaged, meaning there's the silicon.
Yeah.
Then there's an optic sitting right next to it on a substrate, so it's not running over copper wire.
Oh, so
and then what you plug into is an optical connector. There is no silicon. I mean, there is no copper.
Yeah.
The optical connects directly to the silicon.
into the silicon. So like the A to O conversion happens actually on chip.
On chip, yes,
Yeah.
exactly. But that's just going to create an operational and logistical challenge, and that now your silicon vendor and your optics vendor has to be the same.
Yeah.
Right, and your cabling is all optical. It's a big step, and we're still trying to solve a bunch of the technical challenges of how to make this work.
That's interesting. I wonder. So, will now this kind of the substrate be kind of like kind of optical modes, that go right into the chip, set, and so you have kind of like both lasers and detectors, like right there. And
it's an electrical signal that goes into the optic, but it's on a laminate substrate, so it doesn't have the parasitic effects of a copper wire. So it's literally you put the two silicon die right next to each other, and that's how you can achieve the really high speed.
Wow.
It's super complicated, and sort of in full disclosure, nobody has worked this out yet. Like we the industry are still working on how to do co-packaged optics at scale. So kind of good news is we're working on it. You know, the bad news is that doing AI networking can be very complicated.
Yeah.
Right now we're talking about hardware and we're talking about stuff that's 3 years out. But as Cisco, we have the advantage of sitting. We kind of have a front row seat to like what the cutting edge looks like.
Yeah.
We learn from that, like the programmability we talked about in the switch, and then we bring that into the enterprise to make it easy for the enterprise.
Yeah.
And this is my sort of mission and my passion is how do we take this crazy stuff we're doing at the high end, where there's liquid cooling. And these guys literally buy nuclear power plants, right?
Yeah, it's crazy.
Crazy.
Yeah.
Are you going to buy a nuclear power plant to run your data center? Like, I hope not, right?
And they have fixed space too.
Yes. Exactly. Right. So there's a lot of work that the industry needs to do to make AI infrastructure consumable for the enterprise. I can tell you we're on it.
Yeah.
And this is the heart of our partnership with NVIDIA is we're trying to make this stuff consumable for the enterprise customer because enterprises are going to want to deploy this stuff in their data center because it's next to the data that they have. For security reasons, economic reasons, and speed of light issues where you want this stuff in your own data center.
Yeah, I think, it's almost like we've seen a little bit of this story kind of play out in the cloud where there was a lot of kind of hesitation. There still is hesitation around like having workloads in the cloud from a security point of view, IP leakage point of view, and so forth. And that's going to play itself out also in the AI space as well.
The parallels are really similar. However, I think the data leakage issue is even more challenging because there's an inherent tension with AI in that when a model learns your secrets, it never forgets. You can't delete. It can't undo that because it's not like a field in a database. It gets infused into the model, and that's it. You can't go after it. And so protecting intellectual property in a world where the models can absorb this data and kind of maybe they're not going to give your source code away, but if it was going to be giving away some of the ideas, that's actually the hard part of this, right? The intellectual property. How do I ensure safeguards around that? It's pretty muddy. Right? That's not assured. And so we do think that having air gaps, having premise-based infrastructure, whether it's for sovereign reasons or intellectual property protection, we think that's going to become increasingly important.
Yeah, and I think the whole the data stewardship is really key, and the IP leakage is like really one of the critical pieces.
And what's funny is like we've been doing this a long time, right? It used to be everything was in the cloud. It was like, Tom, how fast can you get your stuff in the cloud? I'm racing to get all in the cloud. In the last 2 years, it's gone the other way. Where people are like, no, we want it on-prem. For sovereignty reasons, for there's just a lack of trust, unfortunately, across international boundaries, right? So in Europe, they're saying, hey, great, it's running on Amazon, but we need this running on our own infrastructure.
Well, even that, okay, so this is Wednesday the 23rd. On Monday the 21st of October, AWS went down. And it's like I am personally so happy that we don't run our registration system on AWS. If that would have went down, we got almost 200 registrations yesterday.
It's called business critical.
Well, for us, that was like business critical. So and I know it's like we had this whole discussion. We had a board conversation yesterday about this, and it was back in 2014. 2014, that we were starting to talk about multi-cloud. And a lot of people were like, okay, well, why multi-cloud? Really, all you really need is AWS. And so it's like, these little reminders, really are kind of helpful, to remind us that this is really a multi-cloud kind of world.
Heterogeneity is always good, right? And sort of a diverse infrastructure is going to give you a better outcome than all your eggs in one basket.
Even
Common
better.
sense there.
Yeah. So one other thing that you talked about that I wanted to kind of hit on. So repackaging, or not repackaging, but like packaging products for the enterprise marketplace for AI infrastructure.
Yes.
That's on its way. The other is the operational model. You gave a data point that I was really blown away with. Basically, you're saying like around system data, these are trace logs, alerts, alarms, so forth, like 2 to 3 multiple.
Orders of magnitude.
Orders of magnitude. Like, that's, that's
so
10 1,000 times,
yes, correct. 10 to 100,
bigger,
10 to 1,000 times more data, right? Which is just incredible.
It's incredible. It's, that's huge. And so the way that we've always dealt with, operational data is the haystack model, right? So it's like you put all this essentially, somebody throws a needle in that haystack and then you have all the engineers. So,
but the haystack lives in one place on a data lake. That's just not going to work. First of all, it's almost breaking today because we own Splunk, right? And so when I talk to Splunk customers, they're all like, "Oh my God, it's really expensive." Well, yeah, it is expensive. Even if I give you the software for free, ingest is expensive. It burns CPU and it burns storage. And so if you take that model and you throw 1,000 times more data at it, like it's not going to work. And so this is sort of the big deal between Cisco and Splunk combining is that our view is, instead of moving all that data to the analytics, let's flip it around. Let's move the analytics closer to where the data is generated and then federate search capability across it. So instead of a data lake, you've got a series of data ponds, local data repositories. That could be an S3 bucket, right, out on Amazon. It could be data living in Snowflake, but it could be your Cisco Firewall Log Manager is gathering that data locally. We can search it, we can analyze it with no ingest. If you're a Splunk customer, you hear this, like not ingest. I'm not saying the ingest is free. I'm saying you don't ingest it at all. That's a big deal. And I think that's the only way to scale to this AI world we're moving to. And, we tend to focus on AI applications in the data center. But what I think is really cool, and again, we could do another podcast on, is AI is going to really break out of the data center. And I think it's going to be the thing that drives edge computing. I feel like the industry was all waiting for this revolution in edge computing, and it kind of happened in pockets. Retail, right? It was doing it. So hotels and point of sale, IoT a little bit. Factories, manufacturing, but it wasn't widespread. I think AI is going to be the thing that makes it widespread because we're going to find robotics and AI systems that are in our everyday life. The robotic coffee maker, the robotic bartender. These are real things. Thank God, robotic bartender, right?
Dude,
are you kidding me?
Hey, I'm a big gardener. I want a robot to help me garden.
Definitely. It'll go out and it can tell the weeds from the plants, right?
It's like, just prepare the beds, it's like, all that kind of stuff.
It's gonna happen, and so data is going to be all around us, and we just have to have a different architecture for that. What's the common thread to all this stuff? It's the network. Right? Which is why I think ONUG is coming back to what we talked about in the beginning. Like ONUG is the place to learn about these massive changes that are coming at us, not in years. This is happening in months. Right?
It's scary fast, and I don't think the industry's really comprehended it. It's like when we did the polling, and the polling data that I showed, like in the opening, is like there's like people haven't wrapped their mind around that the infrastructure needs to change. They haven't put budget for it, but they believe it's all going to happen. They just don't have the time scale right. And so
well, what's going to drive that is the business. Right? So case in point, I think one of the killer apps for AI is AI coding. We have 12,000 developers in my organization. 12,000 developers, and when I look at these tools, Windsurf, Codex from OpenAI, like, they're unbelievable. This is like my developers can be not 20% more effective, 200% more effective, 300, 400%. Like this, it's this surge in productivity. Unbelievable. It's unbelievable. So we're going to use these tools regardless of how ready the infrastructure is. So the infrastructure needs to catch up, and it needs to catch up fast. Interesting times we live in, right?
For sure. But before we close, I want to basically kind of recap. So you're thinking operational data is going to be more distributed and federated. And that doing the analytics on all that data will be centralized, but it'll be kind of utilizing agents to interact with multiple agents that are distributed all across that.
The analytics will be somewhat centralized. It's very difficult to decentralize, complex analytics because you're looking across multiple things, but you can process some of it locally, and then some of it is done centrally, but in a very efficient fashion, right? So you just can't have the current model where throw it all in one big bucket and we'll go look for it. It just doesn't work.
I'm like, it's ingenious and it makes so much sense, and especially with 100 to 1,000 times like more data coming in. How do you sift through that?
Let's
awesome.
get ready.
Great.
Okay.
Thanks, Tom.
Thanks, Nick.
All right, this was really great.
Take care.
Okay, thanks everyone.